So, leveraging real-time intelligence can help companies accelerate the speed and precision of the business. They can get the operational efficiency by making data-driven decisions with up-to-date data. They can gain holistic understanding of business health, discover actionable insights from making timely actions, and then they can get competitive advantage if they can leverage the streaming data. Though we are seeing the importance of streaming data or data in motion, it becomes for a lot of customers, it becomes really difficult, to manage the data, leave alone getting insights out of the data. So, time-oriented data is becoming difficult to manage, but yet it is critical. Why customers are facing a lot of difficulty with handling real-time data is they have to capture high throughput data from disparate sources. They have to choose among the bespoke technologies we have in our market today. And with all of this disparate data sources and different business stacks, it becomes really hard to leverage the power of AI agents data in real time. So that's where to overcome all of these issues, we need a platform or end-to-end solution which is easy to use, which is easier to get the insights out of the data. That's where Fabric real-time intelligence comes into picture. It creates a unified SaaS platform for end-to-end analytics. It can be right from ingestion, transformation, processing of the data, or visualizing of the data. So Microsoft Fabric is a unified SaaS platform which has all the workloads we require today for our data and analytical needs in one stack. So it has overcome the issues of having different technical stacks and integrating them, and it also has overcome the issues of data silos we had today. And it is able to accelerate businesses with its AI powered insights and actions. And it has copilot features within every workload, which kind of helps developers and business users to get insight out of the data. Using copilot features, they can use the natural language query to get insights out of the data. We will have a look into all of this in the live demo environment as well. Yeah. So as I was talking, Microsoft Fabric is a unified SaaS platform where we have like end-to-end data and analytical workloads, be it data factory, analytics, databases, real-time intelligence, or Fabric IQ, Power BI. It has Copilot features, and it has one lake, which is kind of acts as a OneDrive for all of your data, and it has security and governance inbuilt. But for today's session, we will be focusing in depth on real-time intelligence, how it can help us handling data in motion. So when it comes to real-time intelligence, we see opportunities or use cases across every industries. There are some of the examples which are listed here. If you take automotive industry, it can be your autonomous driving. In terms of manufacturing, it can be predictive maintenance or predictive inventory, or in terms of finance and insurance, it can be fraud detection, or in terms of helping operational efficiency, or when it comes to retail industry, it can be supply chain management or inventory tracking, or in terms of healthcare, it can be emergency response, clinical decision support, or hospital operations. So real-time intelligence has use cases in every industry, and Microsoft Fabric helps with these kind of use cases, right from helping with the predictive maintenance, predictive inventory management, management, inventory tracking, and even, having a emergency response in the healthcare industry. So, coming to Fabric real-time intelligence, these are all the components we have within Fabric real-time intelligence, as you can see in the slide. Coming to the components, real-time hub is the first one where we have like central space within the Fabric where we can, access data or like transform them and then visualize them all in one place and act upon it. So after that we have like event stream, which kind of like helps in ingestion and processing. Event stream can, listen to your data in motion. It can, get the messages, even do the lightweight transformations, and save them in the different data storages. And then we have like in the analyze transform phase, we have like event house, which is a data storage within the real-time intelligence. It has real I can say it can take data up to uh, unlimited, data up to infinity, I would say, like petabytes to gigabytes. So it has a like very good scaling as well. You can insert how much ever data you have in your organization, and it will be able to handle and scale. So that's about Event House. With Event House, we also will be by default, given Cakewell database. Cakewell database will be created when you create the event house. And then we have Cakewell query set, where you can get insights out of your data, or you can do aggregations there. And we have like RT dashboards, where you have dashboards which you can visualize your data on the go. So our difference between RT dashboard and Power BI dashboard is RT dashboard has like support to live data. As soon as your data gets into event stream and event house, that will be reflected in your RT dashboard. And next we have activator, where you can act upon your data whenever there is any trigger, any changes in the data. It can, create alerts which can be, circulated to Teams or Microsoft Outlook, or you can even trigger a Power Automate workflow or like third party solutions when there is a change in the data. And we have maps as well, where you can, within Fabric, you can analyze your geospatial data without having not much knowledge on the geospatial data. With low code, no code tools, you can, act on your geospatial data. And digital twin builder is where you can simulate your operational and physical environments, so that you know like how those systems perform in your Fabric environment. And then we also have like a Power BI integration, where you can, like if you want to analyze your data furthermore, you can, create Power BI reports over here. So how we are able to create Power BI reports is, once you have your data in the event house, you can, there is a option to enable syncing to one lake, where you can use this kind of data for like further analysis, and then you can create your Power BI reports out of it. And as you can see, we have like n number of connectors which are supported in the event stream, which can be Azure IoT Hub or MQTT protocols, or your SQLs or MySQL, PostgreSQL, and so on. All of the SQL CDC changes, everything can be, streamed into event stream. This is all about the components of Fabric real-time intelligence. I just want to understand if there are any questions. Are we good? If we are good, I can go ahead and yeah. So I take it as a S. So I was telling Microsoft Fabric, real-time intelligence, different components where we have like event stream, event house, maps, KQL query set, real-time dashboard, and activator. All of this, like ingestion to visualization happens in 5 stages. First, we have like streaming where we have like connectors, event stream, and so on, and we have then analyzing phase where we have like event house and anomaly detector, and then we have like modeling phase where we have like maps, graphs, and digital twin builder, and then we have visualization part where we have like KQL query set and real-time dashboard, and then we have decide and act phase where we have like activators and operational agents. This is what I wanted to give an overview on Fabric Real-Time Intelligence. Let's get into the portal and see how it works. So I am creating a workspace within the Fabric environment for the purpose of this demo. And then I'll go ahead and choose my Fabric capacity. And I'll choose the capacity which I want to use for this demo purpose. So once we have the workspace, we can start with the real-time intelligence demo. Yeah, as I was showing, this is the real-time hub where we can, like where we can start with ingesting our data, creating event stream, and then, getting visualization, creating visualizations and getting our insights out of it. So let's head to the workspace I have created. I'll start with creating my event house where I can store my event stream data. Let me search for event house. I'll just say RTI webinar. So it will create my event house. Also, it will create KQL database within the event house by default. As I mentioned earlier, you can see I have my database and I have like monitoring space where I can check, and you can see like there is a KQL database which has automatically been created. And if you go into the KQL database, you can enable this availability to one lake. Once you enable this, you will be able to connect your event house data to one lake later on for further analysis. So now we have connected to one lake as well. Our event stream is ready. Now let's go to the RTI hub and start ingesting data. I will start with add data, and for the demo purpose I will go for sample data today, and I will choose this bicycle rentals. And you can see it has created my source name, and I also have a event stream which is being created. So I will just say bike event stream and then say next, and then I will connect. So it will take some time to create our event stream. Once we have the event stream, we can, see how we can add our data. And if we want to do any lightweight transformations, and then we can store the data to the required data storage. Yeah, so we have our event stream up and running. Let's go to the event stream. So you can see I have my sample, I have created a event stream, and I will go to the edit mode, and I'll do some lightweight transformation not doing any aggregations here. I'll rather choose the fields or probably add the required fields, and if I want any custom fields, I'll add. So I'm adding all the fields from my source database, and I'll also add custom field for analysis purpose. So I will take this current time and say bike underscore current time, and I will save this. So you can still see there is some red mark because we haven't added the destination. So let me choose the event house. I will go ahead and choose the event house I already created. This is RTI webinar, and then I have the KQL database which is inside my event house, and then now I'll create a DB. I will say bike underscore DB, and then I will save. So once you have created all your things, you can just view the preview of your data, and then you have to publish your data to get it loaded to your event house. So it's been successfully published, and let's take the data preview. You can see my event house is getting loaded. It will be there in some time. Before that, we can understand what are all the columns we have. Like we have a bike point ID, we have street information, we have neighborhood information, and then latitude, longitude information, number of bikes in that bike point ID, and number of empty docks. These are all the information columns we have. So let's see how we can, visualize and get insights out of this data. So my event house is still loading. Let's go ahead to the event house and see if it is already loaded. Let's refresh one time. So I still have my tables to be created. So let's wait for our event house to be loaded. Yeah, it seems active now. So now we can head to our event house, and you can see my bike DB which has been created, and there is a data being loaded as well. You can see the um, details about it as well. And now let's do some insights out of it. So let's create some KQL query set for the insights. Here in the KQL query set, you can do aggregations, you can get insights out of your real-time data very quickly. um, so what was our table name? This is my table name. So I will run and see 100 records, and I will see what is the count of my database at the moment. It says 1260. It can change again as well because it's streaming in real time. And then run this. You can see the ingestion time and ingestion count as well. You can see there is a change in the count as well. So I have some of the sample queries which I have already created for this demo purpose. Let me get them. Just a second. So I just wanted to show how you can, get insights in this. So we got the counts, we got the 100 records, and so on. Now, let's see. I'll try to create. Okay. That's because my database name was different. So I'm trying to project the columns based on my neighborhood Chelsea, and let me see if I have current time in this, or what I can do is I will run this again to see what are the column names. So number of bikes. So let me create this chart. So I'm still having some error. Uh, let's go ahead and take help of Copilot. When you get insights from my bike BB, where neighborhood is Chelsea. Let's see how Copilot will be able to help me. So it will create a query for me, which I can insert and get insights out of it. Let me see if I can. Yeah, let me copy this and paste it here. And you can see I have got my um query, and I was able to run with the help of Copilot. How this is how you can make use of your Copilot features within your KQL query set as well. And if you are very familiar with your SQL kind of coding, you can make use of that as well, where you can just put the SQL code and say explain, and you should be able to run this. Okay, so I'm just trying to run where number of empty docs is less than 5. You can see I have some code which I can copy and run it. So this is my KQL query. So if you are familiar with SQL coding, you don't have to learn KQL query language. You can just make use of Copilot and even your like explain syntax. This is how you can, get insights out of your data. I want to save this to a dashboard. Let me do that. So I'll create a dashboard, and that will be saved in my workspace. So you can see I have, like added a table here, uh, and then I can go to my KQL query set. I have saved this dashboard as well. Now I'll go to my KQL query set and try to insert one more. Uh, Let me see if I'll be able to. So let's see if I can run this. So let me change my database name. Yeah. So you can see I have been able to create a column chart as well, which I will save to my existing dashboard. I will say, okay, create to my existing dashboard. I will choose the current workspace. And then once we have saved that, let's go to the workspace, RTA webinar, and look at our RT dashboard. So I was able to add the chart as well. So I can go ahead and edit these styles. If I want, I can add more. I can create here, different tiles and add more visualization. This is how quickly I can get insights out of my data. And now we will look how we can, create alerts. So for that, I will go to my real-time hub. Yeah, let's save this dashboard. And then I will go to my real-time hub. And then I will go to my event stream here. And you can see you can set an alert here. So I'll click on the alerts where you can create your activator alerts. It's just loading. So where you can, create rules where when the trigger will be created. So I will choose like on each event when something happens. So I'll choose my field. I'll say if number of empty docs is um, is less than or equal to, I will say number of 5. So if my empty docs count goes beyond 5, then I want alert, and I want alert to my teams, and I will choose the people as well whom I have to send. I can even choose email as well here, and then I can add the columns, what are all the details I want in that particular uh, alert. So I will choose number of docs and so on. And then after choosing my columns, I can go ahead and choose my workspace for this and where it will be saved. So once I have all my details, let me say it's a bike alert and create. So once we have created this alerts, whenever this event happens, so number of empty docs count goes beyond 5, it will alert through me email, and those particular users whom I have chosen to email, they will get the emails. So this is how like Microsoft Fabric real-time intelligence works in the environment. Hope I was able to give some insights about it. I will now hand over to Niels to share the customer use cases. I'll stop sharing.
Yes, thank you, Nagritna. Perfect. Yeah. So now we've seen a demo and we see what real-time intelligence is about on the theoretical side of things. Now, let me tell you about 2 projects, 2 real-world implementations that I have accompanied in the last 2 years using and leveraging this real-time intelligence workload in Fabric. And one use case that I brought is a bit more on the conventional side, and one is a bit more on the unconventional side of things. So let's jump into the first one, and this is the conventional one. We work together with the company, cannot go into great detail here who we collaborated with, but this company, they are a manufacturing firm based in Germany, and they are running a factory line with sensors. These things here, pretty much industry standard, I guess, by now, that you have some sort of sensors running in your factory line which are able to emit data, and this is also the case for this company. So in this case, we have cognitive assistance sensors which are able to emit data through MQTT protocol. This is really a standard protocol for IoT devices. And the messages they are able to emit, they look a little bit something like this. So for each message, we have an ID, a timestamp, and also most importantly, some sort of process data. So a result and the step name and how long it took, for example. And this company wanted to use this data, of course. It is emitted in second intervals, and therefore you can also react on this data in real time once you are able to do that. And we did that using the real-time intelligence workload. So for this use case, of course, we have as a data source this sensor data here on the far left. And as data consumers, we have the quality assurance department. And what they wanted is some sort of operational dashboard so that you can see in real time what's the status of all our machines through the sensor data. And then also they wanted the possibility to act on this data. So to be able to let people know if something goes awry, or also trigger other workflows within Azure. And between the sensors and our stakeholders, our data consumers, is of course the whole data workflow through acquisition, processing, and provisioning. And we did that by using the real-time intelligence workload. So when it comes to the item stack here, no great surprises. We used an IoT hub to connect to the sensors, and then from there on, we brought the data into Azure and use all the items we just already got to know. So event streams, event houses, KQL query sets, and then for the consumption layer, the real-time dashboards and activator items. And what I want to do now is go through each of these items step by step and say a little bit about each item, what came to mind, what is worth mentioning, and what we found interesting while implementing this solution. And we will start with the IoT Hub. The IoT Hub has been around longer than Microsoft Fabric for sure. It's a platform as a service solution, and it has been the data gateway to Azure for pretty much all IoT devices before Fabric was available. So if you had some sort of device which was able to communicate in MQTT protocol, you would use an IoT hub to get that data into the cloud, into Azure. And now, of course, when you talk about Fabric, the question rises, do we actually need to use an IoT hub to get the data into Azure and then from there into Fabric? And the answer is no. Basically, you could also use an event stream directly in Fabric because the event stream supports the MQTT protocol connector. So it is possible to use the event stream to connect to the sensors directly. In this customer project, however, they already had an IoT hub in place, and we used it to connect all the sensors to the IoT hub and then to have this single entryway into Azure and then connect that to Fabric. After that, of course, we used an event stream. The event stream is really the one tool to get real-time streaming data into Fabric. It is sort of the data pipeline of real-time intelligence. It can connect to an IoT hub or to an event hub or really any other type of streaming data, also to MQTT devices directly, as already mentioned. And it is not only an ingestion device. You can also use other sort of activities and actions within an event stream. So you can filter your data, you can transform it, and you can also route it to different storage locations. And for these three capabilities, I would recommend to use filtering when you can apply it. So if you have certain events which come from your data source, which you do not need for your analysis and action purposes, it is good practice to filter them out in the event stream directly, because this will reduce your data load and also the storage consumption in your event house and everywhere basically downstream. So filtering is a good option. What I would not recommend is using any type of transformations for a scalable solution in an event stream. Transformations are typically done within the event house and using KQL queries. leveraging, for example, aggregations within an event stream will cause more costs when compared to using materialized views, for example, in an event house. So if you use an event stream to get your streaming data into Fabric, try to filter your data if that is applicable, but do not bother use transformations before you get the data into the event house. This would be my recommendation here. After the event stream, we routed that data into the event house directly. So, and at this point, I think it's worth talking a bit about data patterns. So like data architecture, how do we structure our data flow within an event house when it comes to streaming data? And one very popular data architecture when it comes to real-time data is the Lambda architecture, which pretty much only says that you have a hot path for your real-time data, which is as fast as possible, and then a cold path for your streaming or for your batch data, where you would also try to route the portion of your streaming data which is not relevant for your real-time purposes to your cold path. So you have a hot and a cold path, and how does that look like in Fabric? I mean, the hot path, we are discussing it as we speak. The event stream into event house, into real-time dashboard, that is pretty much as hot as it gets in Fabric. So this will be our hot path. And then on the other side, we have a cold path, which would be the classic lakehouse into notebooks and using the Spark engine for your batch processing. So this would be like a hot and cold path architecture in Fabric. And now how do we get our hot data, which is not relevant for our real-time purposes, into the cold path? And that is, as Nagitna already mentioned, the one lake availability, which is able to mirror your event house data from the KQL file format to a Delta Parquet format and then make it available in one lake so it can be used in your Power BI reports as well. And that, of course, happens all in the event house. I'm gonna get into detail there in a second. When you are in the hot path, there are also, you could think, how do you further process your data? And when you check the Microsoft documentation, there's also the talk of a sort of medallion architecture where the Bronze layer is the raw ingestion from the event stream to the event house. And the silver layer is then using update policies to transform your Bronze data. And then a gold layer could be using materialized views to aggregate your data. I will get into this in a second when we talk about KQL queries. All of this happens in the event house. We've already seen it. It is the storage item we use for real-time data. It has two types of storages, the KQL database for the time series-based real-time data, and then the option to make your data available in one lake using the one lake availability type of mirroring option. And for this, we already saw it in the demo that you can enable this on a KQL database level. When you enable it just like that, the data will be mirrored to one lake in a 3-hour interval. So the data that you ingest there, it will be available in one lake after 3 hours. And this interval, you can actually configure that. And you can reduce it to just a 5-minute interval. So if you want to, you can mirror your data every 5 minutes into one lake and make it available as Delta Parquet. And if some of you know a little bit more about the Delta Parquet file format, you might also know about the small file problem. So Delta files are usually not stored in one file, but they are stored in multiple files. So a Delta table usually has a lot of underlying Parquet files, and there is a problem with an excess of small files. So if you have, for example, 100 files and you want to query a table which consists out of these files, you will have a very slow querying performance. And you can imagine when you use one lake availability and you mirror your data in a 5-minute interval to one lake, you will have a very small Parquet file every 5 minutes added to your one lake data. Therefore, you are running pretty much directly into a sort of small file problem when you reduce this this refresh window to 5 minutes. So you want to be aware of this fact and use proper optimizing processes after you make your data available in one leg to avoid the small file problem. And then another thing that we noticed is that the event house as an item, and especially the uptime of an event house, so the state when it's active, when it's running, is one of the major drivers of capacity unit consumption. That means that when the event house is running, which is usually the case 24/7 because you have real-time data which comes in all the time, you will have capacity units consumed by that because the event house has to be ready to receive data and also to process data at all times. And because this is a major driver, you pretty much only want to use one event house for your whole streaming pipeline. So when you think about lake houses in Fabric, you might want to split your medallion architecture into bronze, silver, gold with 3 separate lake houses, one for each layer. You do not want to do that for streaming data in general, because that would mean you have 3 event houses, you have 3 times the uptime cost. The uptime cost is a major driver of CU consumption. So you can pretty much cut your costs when choosing only one event house for your whole architecture. And now then for transforming your data, we use KQL query sets. KQL, we already seen it. It's this, for most people, a bit new syntax with the pipe notation. It is a read-only querying language. If you want to have write operations, which you need when you want to process your data from bronze, silver through gold, you will have to wrap your KQL queries in functions and then in update policies. Update policies are pretty much only schedules which trigger your functions every time new data is in your event house. And then materialized views are probably known to most of you, especially in the data warehouse realm. Materialized views are quite common, so they are used for aggregations. In this project, we only used update policies because we were not in need to aggregate your data. And this is also some learning. If you have a real-time case and you're transforming your data in the hot path, you do not want to take any detours. You do not want to take any extra steps that you do not need. So if you do not need, for example, the silver to gold step where you use materialized views, you should just skip that and make the data available faster, right? Every second pretty much counts when it comes to real-time data. And yes, all of these KQL queries and the update policies and functions are defined in KQL query sets. They are the notebook of real-time intelligence, really. We store our definitions in there. There are 2 types. There is the default KQL query set, which lives inside an event house. So if you open an event house, you are able to query inside there in the default query set of the event house in the KQL database. You can also create query sets as separate items. And my suggestion would also be to use separate items to store your production-ready code of your real-time intelligence data workflow, because it just gives you a bit more oversight. You can store your update policies in one folder, store your materialized views in another, and then you have a bit more oversight than when you keep everything within the event house. And then lastly, the real-time dashboard. Yeah, it's not much to say to this item, honestly. It's pretty much straightforward because every type of KQL query, if you can produce some sort of result in a KQL query, you are also able to use it as a visual in the RT dashboard. So they don't go as in depth, or they cannot produce as complex reports as a Power BI report can, because every visual in a RT dashboard is one-to-one connected to a KQL query. But that makes it also very easy to work with, because every visual is just configured by the KQL query you wrote to produce this visual. And then lastly, we used activators, and this was really the item that was everything about. because we send real-time alertings on top of our data. So when certain values were met, and we found out that there are two types of activators, pretty much. If you have an activator which sits on top of an event stream, you will be able to get the data directly into the activator without any without any delay. And when you have an activator set on a real-time dashboard or a KQL query set, you're pretty much defining a KQL query, which is then run on an interval. So for these rules, which you set in an activator, the KQL query will be sent every 5 minutes, for example, or every 10 minutes. And here for the event stream, the data will be going into the activator immediately. So if you need to take action immediately, you will want to set your activator directly on your event stream data and not on a real-time dashboard or KQL query set. That was the whole architecture here. Just for information, we use an F8 capacity to get this this first POC up and running. And yeah, that was the first scenario. I see we only have 5 minutes left in the meeting. I still have another use case here, and I'm going to try to make it as quick as possible to explain this one. I think this one is really cool because it doesn't have to do directly with real-time intelligence, or not with streaming data at least, but we used the real-time intelligence workload to further improve our regular batch processing use cases, which would be pretty much relevant for everyone, I would argue. So for this scenario, we have already an existing and running data platform in Fabric, and we have various data sources and also various reporting spaces, and a large portion of the source data of this client came from an external data team. And this external data team used an Azure Data Lake Gen 2 to store the data which we are using in Fabric. So the architecture looks like this. We have the external data team, which is working here. They provision data in the Azure Data Lake Gen 2 on a daily basis. And then we have a pretty much cold path, regular Lakehouse Spark workflow here in Fabric. And these different data packages from different data sources were provisioned or are provisioned by the external data team at different times of the day. So for example, we have this API data source being provisioned as a CSV file at 5 p.m. daily. And then we have data from the ERP system being provisioned at 7 a.m. And what we did before using the real-time intelligence workload is that we had our ingestion pipeline scheduled for the same time. So we have an ingestion pipeline for the API data running every time at 5 p.m. Then we have a pipeline running for the ERP data every time at 7 a.m. And this is how we try to close this gap between this external data provisioning team and us working in Fabric. But what happens then if the API data on one day only gets provisioned at 8 p.m.? Our data pipeline, it is scheduled for 5 p.m., right? So this will run into a timeout, cannot find any new data, and our report will not have the latest data. That means we have a failed pipeline run and also data downtime in our reporting space. And we wanted to close this gap using real-time intelligence. And for that, we can have a short look at the Azure Data Lake Gen 2, which is just a data lake storage in Azure. Every action which is performed on the Azure Data Lake Gen 2 is actually an event, and that is being sent to the Azure Event Grid, which is a type of API where it becomes available as an event. And each event has a payload attached to it with the subject, which is the path of where data was provisioned, and also the time when this data was provisioned. And we can use these blob storage events, that's how they're called, as a data source in a Fabric event stream. And this is what we did in this project to close the gap between us and the external data provisioning team. So the analytics data from the Azure Data Lake Gen 2 goes into our copy pipeline. And when data is saved here in the Data Lake Gen 2, the blob storage events are made available in the event grid, and we connected to that using the event stream. This is a standard pre-built data connector in the event stream, the blob storage events. And this is how the blob storage events look like, more or less. We have the time here, and then we have the subject, which is the folder or the folder structure where data was provisioned. And yeah, we then created an activator on top of the event stream to set rules based on the subject. So we filtered the subject for the specific folder. So if we have a folder which mentions the API path, we would trigger the API ingestion pipeline. And the same goes for the ERP data. We would trigger the ERP data pipeline which ingests that data. So when the API data is provisioned at 8 p.m., not at 5, how it's normally the workflow, there's no problem anymore, because the storage event is being sent at 8 p.m. This is caught by the event stream, and this triggers the rule in the activator at 8 p.m., triggering our data pipeline, means our data will be available then after 8 p.m., just as intended. One small thing that we had to work around here, and that is the case where no data is being sent. So if a day was skipped because there was some problem on the source side, usually in our old workflow, we would have our pipeline running at 5 p.m., failing, so we know, okay, something is wrong. Now, of course, when there's no data being sent, there's no blob storage event being created, therefore no trigger, so no pipeline run, so we wouldn't know. And in order to get a hold of this problem, we used an event house to store this data of the event stream, and then we used an aggregation KQL query to calculate for each data source when was the last time that the data was being provisioned. And when this time exceeded, for example, 24 hours, you could use the activator again, but this time with the Teams message notification to send us a message and say, hey, there was no new data in the API folder for 24 hours. You might want to notify the data team. And this is the whole workflow. I rushed it a bit now, considering the time, so I'm sorry for that. But this is how we managed to close the gap for our regular batch processing case, also leveraging the real-time intelligence workload in Fabric. And these are also my two use cases. And I think we're already over time. So yeah, let's wrap this up, Nugget. What do you say?
We just wanted to cover like Fabric IQ, which is a new workload which was announced during the Ignite 2025. This is the next step in real-time intelligence. So, what is this workload is about? Like it creates a semantic layer or semantic foundation to have a like unique or like same meaning for the data across teams, across people, so that AI agents can work on these semantic foundations to get the insights very quickly. So because there is a lot of data, it's difficult when it is in different teams, different departments, different applications. It can have like different meaning, and which might become difficult to get the insights. So that's where we have created this knowledge base, where we have a semantic knowledge foundation. It creates a like business terminology to the data, so that AI agents can get insights very quickly, and they can get the competitive advantage. Niels, can you explain how it can relevant to real-time intelligence?
Yes, of course. So we saw this in the beginning. Fabric IQ is a new workload, and it resides here just next to real-time intelligence. And this is actually to be taken literally, because the integration of Fabric IQ and real-time intelligence is very close. Fabric IQ means we have new items. So we have data agents, and we have, for example, the ontology item. Ontology item is sort of a semantic representation of all your data. And an ontology can take two data sources. One is the lakehouse and one is the event house. So you will be able to create an ontology, so like a sort of map of all your data, including your real-time data, and analyze that visually as a human, and also provide this ontology item as a data source for your data agent. So your data agent, when you chat with them, which is sort of your the chat with your data experience, this data agent will know about all your streaming processes and also all your lakehouse processes. So the interaction or the integration between real-time intelligence and Fabric IQ is very, very close. And yeah, we are very exciting to look forward to try out these new capabilities. And I'm sure we're going to see a lot about this in this year to come. And yes, I think this will be it for today. Thank you all so much for listening. If you guys have questions, if they are in the chat, we are still happy to answer them. Otherwise, you will have the possibility to connect to us via mail. I think there will be a mail coming in tomorrow latest. And yeah, thank you so much for listening and have a good day.
Thank you, everyone.